Okay, the sheets I gave you the other day about solving trigonometric equations. Again, this is assuming we're on this interval from 0 to 2 pi, or 0 to 3/6, which we usually are. This page is probably going to be more helpful to you than the other page when it comes to actually Chapter 7. Specifically, Chapter 7 usually has sine of x equals or cosine of x equals a number. Usually, that's how they're set up. Sometimes, occasionally, you might see a tangent of x equals. Usually don't see secant square, or secant and cosecant or cotangent equals. It's usually one of these three, and more often than not, it's the first two. All right? If you're stuck to the 0 to 2 pi interval, if you have sine of x equals number, x equals inverse sine of y, and pi minus that. Example, sine of x equals 0.1. 0.1 is not one of those 5 numbers, right? It's not 0, it's not a half, it's not the square root of 2 over 2, square root of 3 over 2, or 1. All right? So what I would do, in radians, I would do inverse sine of y, of 0.1, sorry. So inverse sine of 0.1 gets me the answer, 0.1002. But I also get a second answer by doing pi minus that answer. So pi minus answer gets me the other one, 3.0414. Okay. If I try sine of 3.0414, it should equal very close to 0.1. 0.1000. So what I'm finding is there's sine equals 0.1 here, pi minus that answer gets me the one over here. Both of those are the same height above the x-axis, right? That's what that's doing. So that's what this is telling me. If I'm trying to find all the answers between 0 and 2 pi, and again, it's not on that sheet. The sheet gives you all the answers, right? If it's square root of 2 over 2, sine equals that at pi over 4 and 3 pi over 4. 1 half is pi over 6, 5 pi over 6. Negative square root of 2 over 2, 5 pi over 4, 7 pi over 4. So they're there. But if it's one of these numbers that isn't on that sheet, you have to use your calculator to get an approximate answer. The other approximate answer is pi minus that answer. Okay. One thing that I didn't think about before, but I got asked this morning and I had to figure it out. Good thing I wasn't recording that. Suppose it's that, negative 0.2. And again, I'm going to use my calculator to get the answers. So if I do inverse sine of negative 0.2, it gets me this answer here. Negative 0.2014. If I do pi minus that answer, it gets me the pi minus answer. It gets me the other answer, 3.3430. All right, so I would write x equals 3.3430, comma. I did not write negative 0.2014 because that's not between 0 and 2 pi, is it? It's negative. All right. What I remember though is that we have coterminal angles, right? So if I'm at any spot and I add 2 pi, I get the same spot. If I subtract 2 pi, I get the same spot. If I have a negative angle, which is negative 0.2014, and I add 2 pi to it, that's the same answer, 6.0818. Those would be the two answers I would want to get. So again, get the answer your calculator gets you. Go ahead and do the pi minus answer just like you're supposed to get that answer. But then you got to take this negative answer and add 2 pi to get the positive version of the answer you're looking for. And if I try both of those out, sine of 3.3430 comes out to negative, hopefully 0.2, negative 0.2000. If I do sine of 6.0818, it should be the same-ish. Okay. Again, I'm rounding these, so these aren't going to be exactly right, but 4 decimal places are right. All right. So that's what this is telling you how to do. All right. So if you get trig function equals number, and it's not one of those special numbers on our sheet, we have to use our calculator. That gets you answer 1. That gets you answer 2. For cosine, that gets you answer 1. 2 pi minus answer 1 gets you answer 2. Tangent inverse gets you answer 1. Pi plus tangent inverse gets you answer 2. Okay, so different trig functions have different rules. For the inverse trig functions, or not inverse, but the reciprocal ones, cosecant's 1 over sine, right? So just imagine this. If cosecant is equal to y, that means 1 over sine is equal to y, right? Which means sine is equal to 1 over y. If you flip both things over. So if I do inverse sine of 1 over y, that gets me answer 1. Pi minus gets me answer 2. For secant cosine inverse, 2 minus cosine inverse, for cotangent, tangent inverse, and pi plus cotangent inverse. Each time though I'm doing the reciprocal of the number on the other side instead of just the number. That's how you handle those. Again, those don't happen very often, and chapter 7 don't happen at all. But again, this chapter is all about solving trig equations, so if they happen to show up in this chapter, that's how you handle it. If it doesn't make 100% sense to you, just talk to me about it when you get the problems, and I'll try and walk you through an example. Example 3 is a quadratic structured trinomial. Okay? Going back to the very first week we were in this class, we did stuff that was quadratic in form. Recall that? Like x to the 8th, x to the 4th constant equals 0. We had x to the 2/3, x to the 1/3 constant equals 0. That's that quadratic structure. Something squared, something to the first power constant equals 0. That's a quadratic structure. Whenever you have a quadratic structure, the quadratic formula can be used. And if you use the quadratic formula, what you're solving is for that. I'm not finding out what x equals, I'm finding out what cosine of x equals. So if I use the quadratic formula here, I'm going to create a quadratic formula structure, but again, I'm not finding out what x equals, I'm finding out what cosine of x equals. Once I know that cosine of x equals something, then I can go ahead and do an inverse cosine to find the answers, right? Then, as far as a, b, and c are concerned, a is equal to positive 3, b is equal to negative 5, and c is equal to negative 4. The three pieces of the quadratic formula, piece 1 goes here, that's the opposite of b. Piece 2 goes down here, it's 2 times a. And piece 3 goes in the radical, which is b squared minus 4ac, which is going to be 25 minus 4 times 3 times negative 4. So it's going to be 25 plus 48, which is 73. Not too much difficulty, we can find that out pretty easily. Okay. That is not one of those special ones, right? It's not 1/2 or square root of 2 over 2, square root of 3 over 2. That's not on my sheet. Okay, and that's what I'm getting across to you here, is that they're not always on your sheet. So sometimes we have to use inverse trig functions on our calculator. Okay. What I'm going to type in my calculator is this. Cosine of x equals that thing. If I figure out what that thing equals, 5 plus the square root of 73. That's the top. Hit equals, and then divided by 6, equals again. The other option is put parentheses around it and then divide the whole thing by 6. 2.2573. So cosine of x equals 2.2573. And then cosine of x equals, and if I do that same thing subtracting, 5 minus the square root of 73, in parentheses, equals, divided by 6, equals, negative 0.5907. Cosine of x, no matter what x is, I can do cosine of anything, right? What's the biggest answer I'm going to get out of cosine of x? If I'm doing the cosine curve, it's fluctuating between 1 and negative 1, right? Mm-hmm. Highest point 1, lowest point negative 1. So cosine can equal anything between 1 and negative 1. When you see a statement like this, cosine equals something bigger than 1, hopefully you immediately go to that. If you don't, if cosine of x equals that, then I should do inverse cosine of that, 2.2573. Your calculator will say error domain. That just means you can't do it. It's not possible. You can't inverse cosine a number bigger than 1 or less than negative 1. It's not allowed. All right? So no answer comes off of that one. The other one, though, that is between negative 1 and 1, right? Mm-hmm. So there should be 2 answers. That's not one of the answers on our sheet, is it? Not the 1/2 square root of 2 over 2, none of those. So if I do second cosine of negative 0.5907, I get 2.2027. Again, as far as that sheet's concerned, to get the answer between 0 and 2 pi, which is what they're asking me for, right? All that's going to do, the inverse cosine button on the calculator only gives me the answer between 0 and pi, right? There's an answer over, over here also that we need to get. All right, so cosine equals negative 0.5907 up here somewhere, but it also equals down here somewhere, the same place. So to get that second answer, I'm going to do 2 pi minus that. So 2 pi minus my previous answer comes out to 4.0805. That would be evaluate both answers between 0 and 2 pi that fit the question. And again, I can always check. I want to check, type in the equation as it's written. So 3 cosine of x n parentheses squared. Again, that's how you type in a trig function squared. Trig function of x n parentheses squared is trig function squared. Minus 5 cosine of x n parentheses minus 4. If I go to here, my table, and I type in 2.2027 and 4.0805, both answers should be really, really close to 0. 0.0001, 0.0002. And we rounded, we got pretty close, so that means they're probably right. All right, so those are the scenarios you're going to have to go with today. There will be just basic factoring, greatest common factor type factoring. There'll be maybe squaring both sides to create some Pythagorean identity substitution, or you could use a quadratic formula to solve. Again, get the answers. Things that can't be done are empty sets. Things that can be done should be evaluated, and give me all the answers on the interval using those yellow sheets as guidelines for each individual trig function.